Hello everyone, welcome to my video lecturing session. I am M. Hari Kumar, Assistant Professor, Department of Information Technology, St. Martin Engineering College. And today our session is it's a very interesting topic in computer graphics, that is clipping. So there are 4 areas we have to understand this clipping concept. And what are the 4 areas? So and first one is definition, then second examples, and third one types of clipping, and fourth one obviously is the applications. So now let's see one by one. So what is the meaning of clipping, and what are the types of clipping, and what is the exact example for each types of clipping, and then applications, right? So let's see what is the definition of clipping. So in general thing, we can say clipping is the process of removing the object whatever it is beyond the window. So here also same thing. So it's the technique for removing the object which is lies outside of the window. So say for example, that object may be any lines or any line object. So look at the diagram here. So this is my window. Say for example, this is my clip window and this is my 3-dimension object. So I want to display this 3-dimension object in the particular window. So first I have to clip the portion whatever it is lies outside of the window. So that is this is the object and this is the window. So in general thing, this is in example section we will discuss in brief. Okay. Then what are the types? So there are 3 types in general. There are 3 types of clipping. First one is polygon clipping, then line clipping, and then point clipping. And we'll discuss one by one. Let me explain the one by one. So first one is polygon clipping, and in order to clip the polygon surfaces, I'm going to use one clipping algorithm that is called Sutherland-Hodgman clipping algorithm. So most of the time we are using this Sutherland-Hodgman polygon clipping algorithm only. And here, what is the exact step? So first we have to find the exact vertices, whatever it is, intersect with the window. So once you find the vertices, then you can check whether it is outside of the window or whether it is inside of the window, right? And here there are 4 cases we have to consider. There are 4 steps we have to perform in case of Sutherland-Hodgman algorithm. So what are the 4 steps? So first step initially, so in all the algorithms, the first step is first we have to define the window. So first we have to define the window. So how can we define the window? We know already the window coordinates define the window. So what are the window coordinates here? So this is the window coordinate. So xw minimum and xw maximum. This is the maximum minimum value of x-axis and maximum and minimum value of y-axis. That is yw minimum and yw maximum. This is a common step for all the clipping algorithm. So what is the first step? First we have to define the window. So how can we define the window? By using the window coordinates, right? Then what is the second step? Then second step, say for example, so this is my polygon. So this is before clipping. So this is my window. I want to display this polygon in the window. So but some portions are outside of the window. So what I have to do? I have to clip the portions whatever lies outside of the window. So that is called clipping, right? So for that I am using some algorithm that is very famous algorithm is Sutherland-Hodgman polygon algorithm. So after clipping, after applying that Sutherland-Hodgman polygon clipping algorithm, my image being like this. See, so left side, this is the portion I have to cut. So this is the portion I have cut in the left side of the window, and this is the portion I have to cut in top of the window, and this is the portion I have to cut right side of the window, and this is the portion I have to clip bottom of the window. So for that I am using Sutherland-Hodgman clipping algorithm. So after completion of that Sutherland-Hodgman clipping algorithm, then we can get the window like this. This is for after clipping the particular polygon. So look at here, there is no spaces. There is no space after that top of the window and bottom and left side and right side of the window. So there is no space. That is after clipping the polygon surface. right? And here there are 4 steps we have to use. So what are the 4 steps? So there are 4 steps we have to follow in case of Sutherland-Hodgman polygon clipping algorithm. So first step is perform lift clipping operation. So perform lift clipping operation, and second step, perform right clipping operation, and third step, perform top clipping operation, and fourth step is perform bottom click operation. Bottom clipping. So these 4 steps we have to consider whenever we are performing polygon clipping algorithm. So first step we have to perform the left clip, and second step we have to perform right clipping, third step we have to perform top clipping, and fourth step we have to perform bottom clipping. And whenever we are performing these clipping scenario, then we have to consider 4 different kind of cases. Then what are the cases? Let's see what are the cases. So the cases, so first case, so let's see the case. So first case, so for case 1, so what is the case 1? First one, if the edge is coming from outside to inside the window. So what is the case 1? If the edge is coming from outside to inside of the window. Say for example, this is my window and the polygon edge is coming from outside to inside of the window. So outside to inside of the window. So look at the window here. This is outside and this is inside. So if the polygon edge is coming from outside to inside of the window, then what is the output we have to consider? So for example, the edge of the vertex name of this edge is V1 and V2. So for example, here the edge is coming from outside to inside. So in that case, I have to find the intersection vertex. So what is the intersection vertex? So this is I can mention as intersection vertex. And you have to give a new name for that. That is V1 dash. So here, what is the output? So the output is V1 dash comma V2. So if the edge is coming from outside to inside of the window. So this is outside and this is inside of the window. That's first case. And what about second case? So second case, if the polygon edge is coming from inside to outside of the window, then what is the output? So the polygon edge is coming from inside to outside of the window. So this is inside and this is outside. So for example, if the edge is coming from inside to outside of the window, so this is V1 and this is V2. So in that case, what is the exact output? So V2 dash. So again, the intersection point we have to consider as output for this case. That is second case. So the output is V2 dash. So in case The polygon edge is coming from inside to outside of the window, right? Then third case, so the third case is, so if the polygon edge is completely inside of the window, then what is the output? The polygon edge is completely inside of the window. So the polygon edge is completely inside of the window. So this is outside and this is inside. So the polygon edge is completely inside of the window, then what is the output? So here the n vertices is considered as output for this case. And what is the output here? The n vertices is V2. V2. So this is the output in the case 3. If the polygon edge is completely inside of the window. So this is inside of the window. Then one more case, that is fourth case. The polygon edge is completely outside of the window. Then what is the output? So this is my window and the polygon edge is completely outside of the window. So the completely outside of the window. So in that case, what is the output? The output is, actual output is null. Why? Because the edge is completely outside of the window. No need to display this edge. So simply we can discard the edges, right? So this is discard. The output is null and nothing but discarded. So this is fourth case. So what is the first case? If the edge is coming from inside to outside of the window, then we have to find the intersection vertex, then n vertex as the output. And second case, the edge is coming from inside to outside of the window, we can consider the intersection, which is only output. Then third case, if the edge is completely inside of the window, we have to consider the n vertex as output. And fourth case, if the edge is completely outside of the window, then no need to consider that particular edge, and simply we can reject the polygon edge, right? The next one, and what are the scenario we have to follow in case of polygon clipping algorithm? So whenever we are performing 4 different cases, we have to consider the first step output as an input for second step. So look at the example here. So this is my window and consider this is my polygon. This is my polygon. So first, what is the first step? So first I'm going to apply the left clipping. So after performing left clipping, and this is the portion I'm going to remove. So after removing the left clipping, so what is the output? So this is my output. So after clipping the left portion of the polygon, so this is my output for the step 1. So first step. So whenever you are performing first step, that output is treated as input for second step. So second step, maybe I can do top clip or bottom clip or right clip. So the order may be anything. You can start from bottom clip, or you can start from right clip, or you can start from left clip, your wish, right? Then the thing is, the output is treated as input for next step. So here I did already left clipping. So now I am going to perform top clipping. So after clipping the top of the polygon, the output is being like this. So this is for step 1 and this is step 2, and so this is the output for step 2 and this is treated as input for next step. So what is the next step? Maybe I can perform bottom clip or I can perform right clip. So here I'm going to perform right clip. So after performing the right clip, my window being like this. So after performing the right clip, the fourth step is, so after performing the right clip, so my window being like this. So this is for step 3. So step 3, I perform a right clip of the polygon. So after performing the right clip, the polygon edges being like this. So this is step 3. And fourth step, I'm going to perform bottom clip. So what is the fourth step? Just I'm performing bottom clip. Whatever the portion which is lies outside of the window in the bottom, then I'm going to remove that portion. So finally, so this is my output after performing all 4 steps. And this is my final output in the step 4. So in the step 4, right? So these are the steps we have to consider in case of polygon clipping algorithm. So for example, I'm going to explain with an example how can perform this steps whenever we are performing polygon clipping. And during that time, we have to consider the 4 different cases. Already we have discussed that 4 different cases. The case 1 is if the edge is coming from inside to outside of the window, what is the output? The edge is coming from outside to inside of the window, what is the output? The edge is completely inside of the window, what is the output? The edge is completely outside of the window, what is the output? So that is the case we have to consider whenever we are performing these 4 steps. Okay, let me explain with an example for this clipping. So for example, I'm going to consider the polygon. So this is my window. So this is my window. Consider the polygon, this one. So this is my polygon. So this is initial. So what is the initial step? So initially I have to set the window first. So initially I have to set the window first. First I have to set the window first. Then second, you have to mention the vertices name of the polygon. So here I am using the vertices A, B, sorry. So here I am using the vertices V1, V2 and V3. So there are 3 vertices here, and based on the direction you can mention the arrow mark. So based on the direction you can mention the arrow mark. So this is the arrow mark. So why? Because the arrow mark has to consider in the 4 cases. So that is why I mentioned arrow mark here, right? So first I'm performing left clip here. So left clip means whatever the portions available in the left side of the window, I'm going to clip, right? So that's 4. So what are the left side portions available in the polygon clipping? This side, this left side, right? So first step 1. So I'm going to perform left clip and first write down whatever the vertices available in the polygon. So what are the vertices available? V1, V2 and V2, V3 and V3, V1, right? And here V1, V2. So what is the output? See, the polygon is V1, V2 coming from outside to inside of the window. So in that case, what is the output? So we have to find the intersection point, that is called V1 dash. So now the output is V1 dash V2. So why? Because the polygon edge is coming from outside to inside of the window. So the edge is coming from outside to inside of the window, right? So what is the output? V1 dash V2, right? Then second one, V2 and V2 dash, V2 and V3, and this edge completely inside of the window. See, so this is completely inside of the window. The edge V2, V3 is completely inside of the window. So in that case, what is the output? If it is completely inside, we have to consider the n vertices. What is the n vertices here? V3, right? Then what are next? V3 to V1. So V3 and V1. So here, look at the direction here. The edge is coming from inside to outside of the window. So this is inside of the window and this is outside of the window. So the edge is coming from inside to outside of the window. So in that case, what is the output? You have to consider only intersection vertices. Here the intersection vertices V3 dash I have mentioned. So the output is V3 dash. So this is for first step. Whenever you are performing left clipping, you have to consider that 4 cases. So what are the edges here? V1, V2, V1, V2, and then V2, V3, and then V3, V1. And first case V1, V2. So V1, V2, the edge is coming from outside to inside. So if it is coming from outside to inside, the output is intersection vertex along with n vertex. So that is intersection vertex along with n vertex. And second edge V2, V3. This is completely inside of the window. So if it is completely inside of the window, then I have to consider the n vertex as output. So what is n vertex here? V3, right? Then third case V3 to V1. So this is coming from inside to outside of the window. So in that case, I have to consider the intersection vertex. So this is the intersection vertex I have to mention. So intersection vertex. So after clipping this portion, and what is the output? So the output is being like this. So after performing left clip, and meantime we have to consider that 4 cases. So what is the new vertices I have found here? V1 dash, and here V2, and then V3, and then V2 dash. And this is the portion I have clipped by using left clipping. And during that left clipping, I have to consider these 4 cases. Whether the edge is coming from outside or whether the edge is coming from inside, or the edge is completely inside or the edge is completely outside, right? So this is the output for after performing first clip, and this is left clip. So next step I'm going to perform bottom clip. So next step I'm going to perform bottom clip. And what is the vertices? What is the vertices available after performing the first left clip operation? So that is treated as input for second step. So what is the second step? Here the second step I'm going to perform bottom clip. So first I have to write what are the vertices available. The vertices is V1 dash, V2 and V2, V3 and V3, V2 dash. So these are the vertices available after performing left clipping operation, right? And this is inside of the window and this is outside. So here now I'm performing bottom clip. So bottom clip, since this is the boundary line. So this is the boundary and this is the inside of the window and this is the outside of the window. So I'm performing bottom clip and this is the boundary and this is outside of the window and this is the area inside of the window. And V1 dash V2, if you consider V1 dash V2, this is completely inside of the window. So in that case, what is the output? So as per the case, the output is V2. So why? Because this V1 dash V2 is completely inside of the window. So the output is obviously V2. And second V2, V3. So V2, V3 and this is completely outside of the window. So if it is completely outside of the window, so no need to consider, just you can discard the edge. So the output is null, right? So this is for second edge V2, V3 and V3, V2 dash, V3, V2 dash and this is also completely outside of the window. So what is that? V3, V2 dash completely outside of the window means what is the output? Again we have to, so again we have to mention the vertices null. So the completely outside means no need to consider, just we can discard the edges. So after performing bottom clip, the output is being like this. So after performing the bottom clip, the output is, like this. So what are the edges? V3, V2, V1 dash, and this is the output after performing bottom clip. And fourth step is top clip. So top clip. So whatever the vertices available, first we have to mention, and then we have to use that 4 cases. And now I'm going to perform top clip, and this is outside of the window and this is inside of the window, right? So now see the top clip. So how it is working. So what are the edges? What are the edges available? V1 dash, V2. And what are the edges available here? V2 dash and V3. And so this is the inside of the window and this is outside of the window. So look at the edges first. And one more edge, V2 dash and V1 dash. So look at the edges, V1 and V2. If it is completely inside, what is the output? V2 is the output. So why? Because this edge is completely inside of the window. So this edge is completely inside of the window. Then second case, V2 dash V3. So V3, V2 dash. So second edge is V3 and V2 dash. So again, this edge completely inside of the window, then the output is V3. Again, look at the edge, V2 dash and V1 dash. And again, this is also completely inside of the window, then the output is V1 dash, right? So these are the output vertices. So now what is the final output after performing the clipping operation is? So the final output is, this is V2 and this is V3 and this is V1 dash. And here you can observe the new vertices V1 dash we have find. So the main objective of this polygon edge is whenever you are performing clipping operation, then we have to find new vertices, right? So after performing that clipping operation, the output is V1 dash V2 and V3. So this is for after clipping. So this is after. So this is for after clipping, right? So this is the thing you have to consider in case of polygon clipping algorithm. So one more objective is whenever you are performing polygon clipping algorithm, we have to check the 4 cases along with 4 steps. So 4 steps along with 4 cases. So the 4 cases, first one, if the edge is coming from inside to outside of the window, what is the output? If the edge is coming from outside to inside of the window, what is the output edge? If the edge is completely inside of the window, what is the output? If the edge is completely outside of the window, then what is the output? So that thing we have to consider here. And here you can observe, I found one new vertices, that is V1 dash. So that is also another objective in case of polygon clipping algorithm. So now let's see line clipping. Let me explain that polygon algorithm with one real-time video, right?
No, but double tap it. The blue color double tap.
Yeah. So look. So here. So this is my window. So this is my window. And what is the polygon here? Here I am considering the polygon as star. Right. So what is the first step? First I am going to clip the polygon, this entire polygon. Why? Because some portions are outside of the window. So I have to clip the polygon. And after clipping this one, first I have to perform this left clip. So first left clip. And after that I have to perform bottom clip and right clip and then left clip. So after performing 4 different kind of steps, the polygon being like this. And whenever you are performing that 4 step, you have to consider 4 different cases. That cases already you have discussed. That first case, if the edge is coming from inside to outside of the window, what is the output? So the output is you have to find the intersection vertices. So up to this, you have to find the intersection vertices. And the edge is coming from inside to outside of the window. Again, you have to find the intersection vertices. This is the output. And if the edge is completely outside of the window, then no need to consider, just you can reject the edge. But if the edge is completely inside, then the second vertices you have to consider as output, right? So for example, this is my polygon and here I am performing right clip operation and this edge is, so this edge is coming from inside to outside to inside of the window. So up to this, I have to find the intersection vertices. That vertices I can mention as output. Or similarly, I can apply all the clipping, all the 4 steps for this polygon clipping algorithm, polygon clipping surface, right?